Hello guys, in this video I'm gonna to make exposure box for my PCB manufacturing with photolithography process. The easiest way to describe photolithography process is with this image. Here we have our copper plate as a substrate. On that plate there is a thin layer of photoresist coat. On the top of that coat we need to put our PCB pattern aka mask. When we expose all that to the light, on the places where mask is missing, light can freely pass to the photoresist layer. After a certain period of exposuring, the substrate needs to be dived into the photoresist developer. The parts of photoresist layer that have been exposed to the light will be removed by the developer. So exposure box that I'm gonna to make is nothing else but the box where we can put our PCB coated with photoresist layer and set desired time of light exposuring. So let's jump to build. For exposure light, I will use this 20 watt LED fluid light, which is actually intended for outdoor use and works on 220 volts. I have chosen this fluid light because, as you can see, they are very thin, which is perfect for use in the exposure box. Electronics will be powered by this pre-made power supply that can provide 12 volts and 1.2 amps. Before anything else, I like to test and connect everything on the breadboard. And this is electronics for my exposure box. I will talk more about electronics schema later, but for now you can see that there is a 4 7-segment displays on which is shown exposuring time. There is a 3 buttons as well, which is intended for increasing and decreasing time, and third button for start-stop exposure. This blue relay has role to actually switch exposure light on and off. When the countdown timer comes to 0, exposure process completion will be signalized with the 1 second of high frequency tone produced by piezo speaker. Electronics schema is pretty straightforward. Brain of exposuring box is microcontroller PIC16F886. Display segments are attached to the port A, and multiplexing is done by pins 4, 5, 6 and 7 of the port C. As you can see, corresponding segments of all displays are connected together and each display can be turned on by these low-power NPN transistor switches. Displays are with common anode, so when we send high signal to the base of the transistor, corresponding display will be connected to the VCC. Buttons are attached to the first 3 pins of the port B. I have attached buttons to this port because this MCU has internal weak pull-ups resistors on this port which state can be controlled by the code. Beside that, we can configure this MCU to make interrupt on every detected change on this port. Piezo speaker is on pin RC2 and it is driven by PWM signal streamed into NPN transistor. LED for pulsing 1 second is on port RB7 and relay for exposuring light is on port RB6. When we raise the level of this pin, NPN transistor will activate the relay and exposuring light will turn on. Voltage for whole circuitry is nicely regulated with 7805 voltage regulator, which gives 5 volt on its output. Dimensions of PCB are 87 by 47 mm and it is one-side PCB completely made on the top layer. Before I start with making the real PCB, I like to print it on the paper just to see if it will fit into the plastic container, which will be transformed into the exposure box later. I have drawn the whole PCB on the top side because I have found these interesting small SMD displays which I have decided to use in this project. Because this is the one-side PCB, I will need to insert 15 jumper wires on the bottom side. This is how my PCB looks after the etching process. Green photoresist layer is still on the copper, so I will use the acetone to remove them. After small inspection of the PCB, I have found that I have short circuit on the one place. I have fixed this easily with using the knife and cut the copper that causing the connections between these two routes. Okay, when I'm sure that PCB is good, now I can start with drilling the holes. Before drilling, I like to make these guide holes so my drilled bits will not slide all around and damage the copper pads. After the drilling, I have first soldered the jumper wires. Because the SMD displays will lay down on these solder points, I have thinned them out with Dremel tool as much as I could. Okay, soldering is done for now, and this is how the PCB looks like. Let's do the first test by connecting 12 volts to this terminal. LEDs are working and displays are working as well. Nice. Let's test the buttons. I haven't soldered them yet, but I can do the test with this wire by connecting the corresponding button pad with the ground. Okay, buttons are working, relay is okay, and piezo speaker is working. Awesome. Let's move on further. For holding the glass above the exposure light, I have designed this little box. Exposure light will go directly on the bottom of the plastic container, and it will be surrounded with these walls. Dimensions of the glass is 12 by 17 centimeters, and it will lay down directly on the walls. To prevent the glass to slide out, these holders will be stick to the walls. Now these holders will block any try of glass to run away. Because box is smaller than the plastic container, I have added these spacers on the bottom to make the box centered with the container. I have made all this with 3 mm thick cardboard, so let's jump to build. As you can see, the glass will sit perfectly on its place, and everything goes nice into the plastic container. After the painting the box into the black matte color, it looks like this. Okay, let's put now everything into the plastic container. And this is how the finished exposure box looks like. I have fixed the internal box with these two screws. Power supply has been added as well, and it is connected with 220 volts cable. 12 volts goes into electronics terminal and exposure light is connected with the relay terminal. My only concern during the entire development of this project was whether everything would overheat, because this LED floodlight generates a solid amount of temperature over the time. So I decided to put it to the test. I have taken this temperature probe and put it inside of box. Close it and set the time to half hour and start measuring. On the beginning, temperature was 24 degrees. After 2 minutes, temperature is 28 degrees. After 3 minutes, temperature is 33 degrees. After 7 minutes, temperature is 39 degrees. 10 minutes and temperature is 44. 15 minutes and temp is 50. 20 minutes and temp is 54. I have noticed here that after 50 degrees the heat starts to make the fog inside of box, which is not good, but I let the timer goes to 0. And at the end, after 30 minutes, the temperature inside of box reached nearly 60 degrees. To solve the problem with the fog, I have decided to cut the holes on the top of the box, so the certain amount of the hot air can leave the box and the fresh one can go inside. The temperature of 60 degrees is not so critical, because I will never go beyond 30 minutes of exposuring, but if I do, or if you need more than 30 minutes, then for sure some type of fan will need to be installed on this side of box. Okay, I have drilled the holes on the top of the box, so let's do the quick test again. And after 30 minutes we can see the temperature remain the same, about 60 degrees, but there is no more fog inside of box, which is great. So conclusion is, if you need more than 30 minutes of exposuring, some type of fan needs to blow out the warm and suck in the fresh air. Software for PIC microcontroller used in this video has been written in C, and I have used Micro C IDE from Microelectronica. Code and everything in this video is open source, and it is published on my GitHub profile. Link to this repository I will leave in the description down below. That's it. If you found this video interesting, you can leave a like and support me by subscribing to my channel. Thanks for watching, and till the next time, see ya!